want to cover best practices, talk about meshing, interoperability with like Fusion 360 or other applications. We could have an API hangout, or even a simple roundtable where people come in and we just talk about a different subject. So keep that in mind as we go through this first hangout, and at the very end we'll open it up a little bit to get more ideas, and then later this afternoon you should get a questionnaire, and we would like everybody to fill that questionnaire out and be very open and honest in what you thought about this hangout, and give us any sort of suggestion that you want regarding ideas or anything. Okay, so let's get right into it. And also consider how often you would like to do this. Right now we're throwing around the idea of doing this weekly or every 2 weeks. What sort of interaction do you want? So today for results visualization, we're going to be looking at 2 different models. We're going to be talking about a light bulb, which Todd will look at, and then we're going to look at a stadium that represents the Denver Broncos Stadium. And of course, when we're talking about results visualizations, we're talking about the global surface plots in the models, planes with particle traces, isosurfaces, all these different types of objects that you can add to your result. We're not really going to go over in this kind of presentation more quantitative results. This is more talking about qualitative graphics and visualization. On the right-hand side, there's also Showcase and VRED, which you can then output many of these objects like planes and trace particles, and then bring them into another application to even show even more realistic renderings and things like that. So at this point, I'm going to try to transfer this over to Todd's laptop so he can start talking about light bulb. So just one moment.
Let's see if...
Welcome to GoToWebinar. Webinars made easy.
There we go. Now you guys should be able to hear me. Sorry about that. So this is essentially just an LED light bulb. I've got a couple of variations of it to show you guys some of the walkthrough of the Decision Center stuff. You know, basic natural convection. I've got an air volume flowing around this. Let's go over and kick into results and start to take a look. When you're in the global results, it's going to be a little bit more broadband because I know we have a variation of users. You're typically starting by looking at velocity magnitude. You can change your results and kick over and try and look at, temperature is probably what we're interested in with an electronics model. One thing that a lot of people don't realize, you can go into the options settings and you can actually change the color options. A lot of people have a thermal camera picture and things like that they'll try and put on their web pages, and they don't realize that we could even match that by just changing the coloring for our legend. So now we can take a look at the model and actually see it as it might be from a thermal camera picture. There are a few other settings so that you can do black to white, and I mean a lot of things that can just make your pictures look a lot more interesting, so that you could use them for marketing purposes as well as your just your presentations. One thing that I have noticed with lighting, people like to see how efficient, and this goes across the entire electronics. I'll show you guys looking at watts per meter squared K, and I will change what we are looking at from 100 to 250, and now you can see where the most effective parts of your heatsink are. So we can see that the outside pins for this particular heatsink are the most effective, and if you just you can cycle through the space bar to bring up the decision center. I've already made a couple of summary images. And if you look at, to make it so that you have multiple views, that's in viewports over in the views. Oops, let's get back and look at that. And I can bring up, here's two very similar heat sinks that we have. And I had actually, this is showing the wall flux heat result, and then I have a cut plane in the background for them. You can see that we saved material and have a more effective heat sink just because we removed a bunch of the fins. And now you can see the just the profile for what the heat flux is doing. It's a good thing to look at for anybody that's trying to dissipate heat, to understand how effective you're able to do it. One thing that I think a lot of people don't really understand or notice. Let me go back over to my results. Moving across the ribbon here, I'm going to show you guys real quickly adding a cut plane. Pretty easy to do. And instead of looking at the wall heat flux, I'll actually look at velocity. You can see that I have a nice little plume above my model. Let's recenter that so it looks decent. And you can move your cut planes around and do a lot of things. Royce will be going into that on his model in a little bit more specifics. So I'm going to remove my cut plane and show you guys an ISO surface. Again, I'm starting off with heat flux, so let me change it over to velocity. And I can see how that, right now it's showing me where this specific velocity is. And I can slide to find a specific value. I can also change this into an outline form and look at vectors so that I can see where the vectors of velocities there are and which way they're going. A fairly typical question that we get a lot is talking about running an animation. So in my initial setup, I set up save intervals so that I could then go back and animate each of those save intervals. I saved every 15 iterations, and you can see if I run this guy now, my plume starts to generate as it runs through it. Also, if I go back into my global results, I can look at the model in a shaded form. And instead of wall heat flux, we're going to go back and look at it in temperature. So here I can actually see the model heating up as we run through the iterations here. And then as the heat dissipates, it actually cools a little bit towards the last couple iterations, which is what you'd expect from natural convection. So let me bring up my animation and stop this guy for a second. All right, and let's actually get rid of my ISO surface. The wall calculator isn't anything really for visual results, but we can select surfaces and get specific values. Parts, similar, where I can select a part and look at the temperature across several parts. Points will actually reflect the same thing from the save intervals. If you have like a thermocouple or something like that, a lot of people try to use points, but they really want the data from that point for the entire run because that's how they're getting their test data. Instead of, I added a monitor point before this run, so I can add in that point and I can look at the temperature, which it looks like I missed my part, but normally this would show you the temperature of my part throughout the entire run. Yeah, it gave me all zeros. I didn't check that one ahead of time. That is my fault. Oh, actually, there it is. I just needed to toggle it. No, that's global. 0.1 didn't go. All right. But that needs to be added ahead of time in the setup from monitor points. I'm trying to think if there's anything else I really wanted to get to. I think I'll pass it over to Royce to look at the stadium model for now, and if we have any questions, we can definitely come back and look at anything with heat transfer. And okay. I saw that somebody asked a question about troubleshooting divergence. Since we were already talking about the ISO surface, I'd like to kind of bring that up a little bit. We'll probably have another webinar series that deals with that on its own. But one of the first things that I'll do if I have a model that's diverging is I'll go and I'll add my ISO surface, and you can look through the convergence plot and see which. I'm looking at all of my variables. Usually one of them goes crazy first, so you can look at velocity or pressure or temperature, whichever it seems to be that's going nuts. And if you stop it beforehand, you can add in an ISO surface and look at where your highest value is. It'll usually come down to a couple of nodes. This not being a divergent model, it's not really going to, let me kill these axes. It's actually showing my highest temperature where I would expect it, but it could be out in space, or a lot of times you may see just a weird maximum value that you want to see where that is, because maybe it's just one node on the side of the model. If the model's diverging, a lot of times just tightening the mesh in the area that you're first seeing those really high velocity or high temperature, high pressure nodes, refining the mesh in that area can help blend that out.
How many elements are in the model? Just out of curiosity.
In this model, I am not entirely sure. It looks like I ran this with about 1 million elements.
Okay. Why don't you mute yourself now? I'll take over then on the stadium.
All right. I will pass it over to Royce to talk about the stadium for you.
Okay, is everybody hearing me now? Great. Okay. Okay, thanks. All right, so now we're going to jump into the stadium model. I just want to thank John from the forums for delivering this for me, actually. About a week ago, when we really started to know that we're going to be presenting this week, I posted in the forum asking for ideas, and John came back, and he was the first one who responded, and he said he wanted to talk about results visualization. So that's one reason why this first webinar is just in that topic. So I just want to thank John for giving me this model. And just out of your own curiosity, I just wanted to compare the two models just a little bit. And if you look at the top view from Google Maps of the stadium itself, it seems pretty accurate, maybe on the left-hand side here, which turns out to be the southern end. The stadium isn't quite well, but for our needs, I think it's a spectacular model just to do some result visualization of an external flow profile around the building. And yeah, so let's jump right into it. Okay. So I took the model that John gave to me and I made some modifications to it. One of which we'll leverage for some of our visualizations, was I sliced and diced the geometry of it. This allows us later on to really dive into the geometry and try to see through the model to see different parts of the results planes or isosurfaces and things like that. So as you can see, I can start hiding the different parts. And many users would just take this whole stadium and make this one lump mass. So there's something to think about before you even bring your CAD into CFD, because that would need to be done at that point. So this model, just to cover the quick setup, made the stadium concrete. The ground around the stadium I made brick. Could have been cement, could have been concrete as well. And then, of course, we just have air. And then on the inside in the field, we have a grass material applied. Very simple setup, not too many material types. And then I ran this model with different velocities going across the stadium with some ambient temperature of 70 degrees Fahrenheit and, of course, 1, 5, 10, and 20 miles per hour for different scenarios. Okay. Ran that with a fairly simple mesh. I refined the stadium just a little bit, not extreme, and then ran this out with radiation, solar radiation, all of that run together for all four models. Now, of course, for any CFD model with our software, when it finishes, the default view that you see in results visualization is just going to be velocity. It's not all that exciting for this kind of model. Everything is blue. So the first thing that most people are going to do at this point is just add a plane. Of course, we have all of our tasks up above. You can also access all of them in the right-click menu. And I'm just adding some of these more basic clicks and picks because there are a few users that are attending right now that, based on the polling, that would like to see that kind of stuff probably. Okay, so we're just going to come in, add a plane, and by default the plane comes in right through the origin of the model, perpendicular to the x-axis. Now, as you see right now on this plane, there's all these red hash marks. It's pretty ugly, and it can get bad sometimes with certain models. So turn that off. You can turn off the show outlines right through the ribbon when you have the planes active, and that will turn off that outline. Okay, so I'm going to be going through a few different views of the stadium, trying to interact with as many different features as possible. But before I do that, I want to show you where I'm going to go, at least for the first one, because it's probably the most complex, I guess. So I'm going to leverage our View Settings option, which is under the View ribbon, under View Settings. I'm going to apply a view, pre-canned, and we'll eventually set this up afterwards. So once I apply this, it goes right to where we're going. Now, this is a great tool, the View Settings, when you're during meetings. So you don't have to sit there and fumble through results. So save the view, open up the view when you want to go to another presentation with your team at work. So what we have here are two planes with vectors. The vectors themselves have been filtered. The vectors are at different lengths. The stadium itself has a texture applied to it, the grass is a color, and the ground around the stadium also is a color. All of which leverages many different parts of visualization that we're going to do. Okay? So we're going to go back to the beginning now. The blue world that it is, except for the openings. And we're going to come back in and add in our plane. We're going to move this to the inflow direction, because I want to have my first plane going right through the middle of the model. And right away, after I try to add in my vectors, which, by the way, 2 ways to bring up vector control. You can right-click on any object to get a contextual menu that's pertinent to that object. So I'm going to right-click, go to vectors, and turn on my velocity vectors, which I could also do up here. And by default, vectors usually aren't tight enough for what you want. Or they're too big, too small. You got to do some sort of editing. It's a decent distribution to start off with for the analysis, but I really want to see inside here, and I have 2 vectors. So I'm going to go in and edit my vector settings. And if I want more vectors, change the grid spacing, increases the resolution of or number of vectors, and I'm going to tighten this down a lot. Right away, what we see here is basically a cluster of many, many vectors. They're all the same length, they're overlapping, and I want to take more control of this. So there's this more button. There's also same length or length range. So first, I'm like, well, they're too long. Let's make them smaller. I can do that with the length range. And at this point, I can even add more vectors. Now that looks pretty good, but all the vectors are the same length. I don't really get a sense of how much slower this blue is versus the reds and oranges up in this corner on the left. Okay? So I'm going to switch from the same length to a length range, and then bring in the entire range of those vectors. Now these vectors that are much faster, much larger, are obviously faster. And on the inside, you can sort of see that. Smaller vectors on the inside. But now this is just out of scale. It's just not good. So I'm going to come in, and there's even more settings for vectors. There's tons of settings. And I'm going to use the scale factor, which is used to adjust this range. So instead of a 0.2 or 20%, I'm going to make this a 0.05. Now the vectors on the inside, nice and small, right in the middle of that recirculation. You really get a better understanding of the flow going right over and back on the opposite side over the stadium. But I don't want all these vectors. All these fast vectors, upstream, over, it's just too much. So I leverage filtering. And I want to filter anything less than, let's say, 0.2. And now I want to see the stadium through. I go to outline. And maybe I still want to see some of the reds and blues. So let's make this a little bigger, 0.35, maybe 0.4. You know, it's whatever you want to display. And at this point, now I can really start seeing the vectors on the inside. I see the vectors downstream. My scale still seems a little large, so let's make that a little smaller. And yeah, you can definitely start seeing it. Now, there's other options here. If I wanted to, I can make my arrow heads even larger or smaller. Maybe I want to get rid of them. Just have lines by making that so much smaller. But we'll just keep this default values for now. Okay, so now we can see the vectors going around, recirculating. If I wanted to reposition this, which I'll do with my next plane, I could do that. But either way, now I want to make this pop out around my stadium. Okay, so let's just hide this plane, which in this case, I'm going to do this just by hiding the air. So I'm going to middle mouse click on the air volume. That will hide it. And by the way, some of the clicking may change. I'm using the CF design option, the old interaction, and that might change a little bit. So check the documentation for your exact workflow for hiding. At this point, I'm going to switch to global and start changing some of the visualization for the solid components. Now I could right-click to start making each one of these solid or outline or transparent. That's slow. That's tedious. What you need to do is leverage the design study bar on the left-hand side. And there's a whole results section for all the materials that you have. There's even options in here for the planes that are listed, so I could just see how many planes I actually have. So my concrete, I could make it a color, can use a texture as well. So I'm going to right-click in concrete and go show texture. And then we have many canned textures, and I'm going to use a sphere map. And then I'm also going to make it solid, shaded. For the grass, I'm going to right-click on that. I'm going to make that a color. Make it a nice dark green. It's also going to be shaded. For the brick, we're going to make that shaded as well. It's currently blue because it's showing velocity, because velocity is our global result. So that's going to be on all surfaces of geometry itself. I'm going to make my brick. Nice maroonish color. Okay. Then I'm going to do Control, scroll the mouse button, and bring back my plane. That really makes, in my opinion, the plane pop out around the building. You get more of a depth perception. It just looks good. But let's say I want to have more of a side view in here. I can't see the ground. I can't see the playing field. Maybe there is a massive recirculation region right around the field goal that would be awesome to look at. It doesn't in this case, in this model. But what I can do here now is hide my air again. Now I'm just going to switch each one of these. Actually, I'm going to keep that shaded. I'm going to middle mouse click in each one of the corner parts here. So now I can see on the inside, kind of open up the model. This works great for pumps, by the way, to see the inside, look at the blue and the propeller and things like that. And then I'm going to come back to the air in the design study bar, right-click in the air, and go back to show. Now, we can start peeping in, but we see all these ugly blue lines. And that's just remnants of what would be the surfaces of the air. If we go to transparent, you can now see the surfaces and what was before the edges. Now, a little trick to get rid of those edges is to come in and make that air transparent. Now, it's already transparent. You can do it through the right-click on the design study bar. You can also come in, right-click on the actual body itself, make it transparent. What I'm going to do here is set transparency. Defaults to 50%. I'm going to move this to 100%. Click on OK. Now this really pops out. I have my vectors, I have my recirculation region, and everything looks pretty sharp. I'd love to show this. I am right now. Look at that. Okay, so we're going to come in now, add another plane. I want to see the wake behind the stadium. Okay, add another one. Comes in right at the default location with velocity, and holding down Control, Shift, right mouse button allows me now to move this forward and back. Could also use these controls. If I right-click again someplace, so you can see the triad move. That can be leveraged handily if I want to rotate this around a point. Oop, didn't want to do that. Yep. Sorry about that. We can hang ourselves up playing with the results. Yep. Oh, I see what's going on. There. There we go. We're add another plane. Bring it back into the wake structure. Remember, Control Shift, right mouse click. And I'm going to go back in and add in my vectors. hide my actual plot. You can see how there's like a vector here. The density isn't quite right. So I'm going to right-click, go Vector, Settings, and then from here, change my grid density all the way down. And at this point, we see a nice wake structure. Has the same filtering control and everything else that we did in the first plane. And now we can slide it forward and back in the model. You can see air go up and over the stadium. You can kind of see the recirculation structure in the inside, the airflow going up and around, and eventually downstream, and then sort of slowly dissipate and develop further down. So that's that first one. I told you this is the most in-depth one. Covers a lot of things regarding planes and vectors, which are all great things that everybody should be using. All right, so yeah, plane shifting regarding animation. I see that question came in. Paul was about to probably answer that. You can't actually animate it. It's something we've talked about for years of doing, and basically what you could do, you could shift this to the right and use something like Jing to actually make a recording of the animation. Hide this window, go to Edit, and you can use this move with the scroll key to sort of move this slowly through the model at a somewhat consistent speed. It's not the best workflow, just saying what you can do, and do that as a recording on your own with third-party software. Okay. And no, there's no undo functionality. I see that coming in from John and Jared. A lot of people, yep. I'd love an undo myself. Just for the occasion like I had. Yep. Okay, so that's the first one that I wanted to show. Next one is just kind of going into results. So we're going to go back, or temperature results on all the bodies. We'll go back to my beginning. Back to the ugly blue. And we're just going to change everything here. By the way, middle mouse click hides. And remember, I ran this with heat transfer, solar radiation. What sort of temperatures are we looking at here? So we're going to go to results, switch to global, switch from velocity, temperature. And right away, we can see the angle of the sun in this model. It's about 4 o'clock on September 1st. So this would have been opening game for Denver. Right about that angle. So of course, this is the east side over here, and this is the west side. And east side's hot, west side is cold. And right now we're using the traditional blue to red legend. Maybe I want to make this into Fahrenheit for my range, or for my units. And with my other legend options, maybe I really don't care about 0.768 for this model. Let's get rid of the decimal points. And maybe I want to have less resolution on the number of points in my legend. I can change the number of pixels between labels. Or I can change my thermal camera, or my color options to a thermal camera. Lastly, just to kind of go over legend controls here, if I want to hide my legend, view legends, I can hide it. I can also change the way it looks. This is kind of a large view. This is why it's one for bigger. And I can go all the way down to something extremely small just to have it almost as a reference in a plot in a report. Okay. One common question that comes up, this actually wasn't something I was going to talk about. Let's say I added a plane. Comes in as temperature. I have one legend for temperature. I switch that to velocity. I now have a velocity legend and temperature legend. If I even hide this plane, that velocity stays there, even though it's not really in view. Only way to get rid of the velocity legend is by deleting that plane. Let's say I add in or change it to the same variable, exactly. Let's say I have one for velocity, and I add another one for comfort temperature, another one for shear stress, another one for solar heat flux. You can keep adding these in, and it becomes a big mess. Save the view for what you actually want to show, delete all your planes, and then have just what you want. It's a common new user question, I'm just tossing out there. All right, so that's temperature results. Okay, and let's now go into, all right, so let's say in this stadium, this is the 1 mile per hour, so this is going to be the most hot environment for the people watching the game back in September. Let's say I want to filter out everything in this model except everything larger than 100 degrees Fahrenheit. You can do that. You can right-click off the model, go to Filter Control, or in the results, go to Filter. It's probably why not a whole lot of people use it, because it's sort of hidden. Let's go to Filter, Enable. It takes a moment to process. And now it turns every solid in the model into kind of a transparent gray color. But then at the same time, it filters out any result in the model that's not within 100 and 146.768. Okay. Now, personally, I don't like this gray color. I don't like these edges. It's all kind of bland. So what I do is I switch my color to black. Then I increase my transparency to about 95%. And to me, that contrast of black with a little bit, really highlighting the edges, just makes everything pop. Now, of course, we can then make this a summary image, and really what I want to know is, 1, 5, 10, and 20, how does this look? So I'm just going to turn this off. So I made a decision center plot of just that. And what you'll find out when you do this is that you lose your building transparency. Just a limitation. It's what would happen. But if you turn on, I like to turn on the mesh at that point so that I can see a little bit of depth as the planes move, or the surface elements move around in the model. So at this point, I can just look at my different operating conditions here. So there's my 20 mile per hour. Everything's far less than 100. Then it gets a little warmer, and a little warmer yet. And at 1 mile per hour, tons of people are seeing an environment much higher than 100 degrees. So filter control, planes, global result temperatures. Todd talked about ISO surfaces, but one way to look at ISO surfaces in this model is once you actually add in an ISO surface, let's say I wanted to get a sense of space inside the model qualitatively, adding an ISO surface. So there's an ISO surface right now. For people who don't know what an ISO surface is, as I do this, it's just a surface inside the model and the result that is going on a continuous value that you assign. So this is just highlighting 75 degrees Fahrenheit throughout the entire model. So what we see here is a large 75-degree range at the 1 mile per hour wind speed that is higher on the inside than 75 degrees. Remember, the wind temperature, the environment temperature is 70. And of course, as I start adding in higher and higher speeds, this plume gets closer and closer to the building because now it's becoming cooler and cooler. Okay. Everything's becoming red right now because the velocity itself was initially synced to the slower wind speed. So if I adjust this now, you can see how now the slower wind speed is a lower blue. So it might make a little more sense color-wise to people. Okay. Last thing I'm going to do is traces. And traces are very powerful to visualize flow within a chamber, or anything really with airflow. So you can see where flow is coming from, where the flow is recirculating, where the air comes from when it does go into recirculation region. So what I'm going to do here is come back to my results. Let's go back to our view, apply. We're going to go back to our beginning, hide that. I'm going to hide my air volume. And basically, what I want to know in my little study here is if I take this seat right here and I buy myself a hot dog, who's going to smell my hot dog? Okay, or I get some burgers, who's going to smell my fries and burgers? That's all I want to know. Fair enough. Okay, so come in, add plane, add that in. I'm going to locate this. I'm not going to go through all the clicks and picks here. because we're going a little long. And I'm going to come into traces. There's different ways to apply this. I'm going to pick on a plane. I'm then going to pick or seed my points right along the ground right here, right about where I'd be sitting. Add that trace set. These traces start off pretty large, and once I've added it, I can actually remove my plane. And these traces, I just want to make a little smaller. And visualize everything as a solid. And let's actually change the global result to temperature. Okay. So what happens when you seed a trace particle, most people are going to seed them probably the inlet of their model, is that the trace is going to determine where that, it's going to force that trace to go through where you seed it. So where I seeded it in the model, in this cluster right in here, all those traces will go through that seed point. But it's going to go upstream to determine where the air would have originated from to eventually get to that point. So what we see here is that the air comes right over the top of the building. And eventually recirculates around. And everyone, that kind of first row right here is going to smell my hamburgers and fries. And it's going to kind of curl up over the side of the building, eventually recirculate around. And then everybody in the upper seats are going to eventually get, the aromatics get hungry and go up and get their own food. So that's kind of the quick and dirty of traces. You could also turn on masses. What's funny is that when you first turn this on, the default values, you basically turn it into a kinematic trajectory problem because they're so big and large. Make this into air. Make it small. And let's just make a smaller value for the time step. Time step, all that's going to be is a smaller increment of the physics. And what you see here now is the traces start from where you originated. That's what happens with trace particles when you turn on mass. It starts from the seed point and continues from that origination and moves around. Okay. So at that point, that was all we really had to talk about regarding results visualization. Probably went a little longer than we were hoping, but I think this is an important topic to cover with everybody. At this point, I'd really love people to chime in with questions and answers, and we'll try to answer. Todd and I will be here. Apollo has been active, and I think John has as well. When you ask questions, it could also be suggestions on future topics. They'll record those and get that back to us so we can then make sure we cover them. And also think about how often. Is weekly too much? Is it, initially we almost said twice a week, but that's probably way too much to cover or get content for everybody that's interesting. One potential future topic, that goes right along with what we just did was integration with Showcase and VRIP. These are quick renderings of different models showing traces and free surface. And yes, I can show the tree views again. I can definitely do that, Rex, just a second. So please chime in, add into the conversation. This is all for you. And it's open to anybody. I don't know if you realize, but there are people in this that have been using the software for years that all of us at support have interacted with, and we're great to see them join in. There's others that I've only talked to once, and there's some names here I've never seen at all, which is great. So, view settings. Let's get rid of all this. And there's another one I wanted to show. Stuck traces. We'll show that in a second. I saw that question come in. So view settings, if you go to the view ribbon, so quick 101 here on the UI, these are all ribbons. Under the ribbons are going to be different panels. So this is the panel. And then in the panel, so this is the image panel, are different buttons. So if I go to view, Then there's save and apply. So if I want to save this view at this moment, I can come in. So I have a collection of profiles here. Let's call it test. I want to open it up, and I just go and apply, and then open that file. Now let's say you are in a results presentation. You just want to make this very clean for yourself. You don't want all this noise. Right-click on this icon. Go to Add Quick Access Toolbar. Now it's up on the top. Now I can now open it. In my ribbons here, I can hide this ribbon by going to Clean Screen. And now the whole screen is full screen. Great for presentations. Now I can just go in, open up a result, and boom, it's right there. Okay. Makes all the non-analysts, non-CFD, non-engineers that might be at meetings not be distracted, really. For good mesh sizes, yeah, get that queued up. We'll transfer it over in a second. I just want to answer one question before I transfer to Todd on stuck trace particles, because I can show that within this model. So let me bring back my bar. Let's go to my initial view. Okay. We're going to add in a plane. And we're going to just move this to the upstream. So this is more our standard workflow with trace particles. Actually, I'm not going to seed it there. I'm going to seed it right here. It's right about where the end zone is going to be. And we'll come in, add by rectangular grid, and we're going to add in a bunch here. We'll add in 10 by 10. So we're going to add in 100 points right here. Now we have tons of trace particles. We can see how it recirculates in the inside of the stadium itself. And let's turn on animation. Let's hide all that and make this solid. Let's get rid of this. Okay. Now what you see here when I do this animation, you can see the frames. I don't know how quick that is on the screen. But basically, everything happens in that very first frame. Bam, done. So what you do here, come into the trace list and use the filtering here, or the sorting, to find out the residence time, or how long it took this trace to go through the model. Okay. So there's going to be some really long or really short traces that screw up the timing. So as I look through my 100 traces, most of them are going to be in the E to the 4 range. There's going to be a bunch of E to the 5. There's one E to the 6. Let's get rid of E to the 6. A little better. Now it's kind of going through in about 10 frames, maybe 5 frames. So we're going to sort again. Let's get rid of the E to the 3. And in all reality, what I would need to do is get rid of all my E to the 5s. And now, you can really see the animation go through. Okay, so let me toss this back to Todd. Yeah, making you presenter right now. And
Oh,
are we good now?
there we go. So, one thing that that a lot of people struggle with, and it's always a little bit trickier for figuring out what your mesh size should be. And you can look at these seed points to see really, does it seem like there's going to be a good distribution? Because we see as we get further away from edges, you'll end up seeing that our nodes get further and further apart. And that does translate into the model if I'm looking at it as a shaded mesh. I can see that there are areas that I have a tighter mesh and areas that the mesh is very coarse. And that will affect your results. As I go back, I'm going to kick it into outline, and I'm going to re-show all my air. The easiest spot to see this on a cut plane, velocity is fairly simple, and you can see just that our velocity is following these mesh points, the max velocity. So we know that the mesh is actually forcing it, because if we look at the top of the plume here, let me see if I can slide this down. It doesn't want to listen to me. But as we look at where the max velocity is developing, it almost splits where the nodes are, and you can tell that all that's happening in between points is interpolation. So the width of the element distribution is directly affecting the results, and we're quickly doing a lot of interpolation to capture it. Typically, you want to see several elements across a flow passage. And you can see when there's some higher velocity down near the corners, we actually have even more of following the lines, and it's a nice distribution where there's a larger group of nodes capturing it. Now, that doesn't entirely answer the question, but it shows you from the results side how you can review whether your mesh settings were good enough or where you might want to dig in and change your mesh to make sure that you're capturing good physics. Another way to look at it that is fairly nice, if you change into shaded mesh, I can go into my cut plane and view. C-clip, my crinkle cut. What was it in the planes? I can't remember where to do that from. Here's the clipping on a plane. Is that back in the view? Man, I forget where it is. I can show you how to use the Z-clip with a crinkle cut. So I'm going to be clipping the plane back, or clipping back towards the plane until I went way past it. This is actually clipping by the result. This is 50%, so you can see that. How do I? Okay, I reset that. Here's the plane clip. You can only do it through right click. Yeah. Oh, there it is. Now you can see that I'm looking at the model with the plane actually clipping the model. So I can see it a little bit better as I'm sliding through the section of the model. else for?
No.
I know we're getting close on time, and I do want to thank everybody for stepping in. This has been great. Sorry for any questions we don't get to, but we'll try and grab a couple more.
Yeah, I grab a couple more.
Okay.
Just mute that.
Cool.
Okay, cool.
So, couple more questions
that I saw that came in. I'll just highlight a little bit.
Regarding
videos. So we do have the ability to say about AVIs and things of that nature right from the software. Personally, though, I don't like using our built-in AVIs. What I will do, though, is leverage a program like Jing, J-I-N-G, where you can record up to 5 minutes for free. And you box select or use sub windows within an application to pick what you want to record. I find that produces a higher quality and smaller video file that you can then use. So then you can record your animated traces without having to go to VTFX files, which, by the way, are saved dynamic images, which is kind of up the left-hand corner right now on Todd's screen. So personally, that's what I usually suggest people when they call in regarding videos. So I would definitely suggest that over using our AVI output. Regarding doing this for other products other than CFD, yeah, definitely that. I'm guessing that will eventually happen. This is, by the way, the very first time that Autodesk has done something like this within the product support organization, at least. There is a webinar or hangout kind of thing that the Fusion 360 team hosts every 2 weeks on Tuesdays, and they get together, and it's usually about 10 to 20 people and talk about Fusion 360, which is an up-and-coming cloud CAD package, which which actually I love a lot. I've played around with. So yeah, this is really a beta of delivery. It may change with time a little bit. Future posts will be, I'll post it on my Twitter feed if people do that. I don't know. But definitely will be in the forums, and most people probably learn about this through the email invite. I don't see that going away, and that same group will probably invite again, so you'll be included. And if there's mechanical cases or mechanical, that will get advertised as well. So keep a lookout. If you do Twitter, monitor that. We'll definitely post any future sessions right there. So at this point, it's 12:03, so we went 3 minutes over, and I think it's a great place to end. So I want to thank everybody for joining. This has been recorded and we've posted to YouTube. Give us a few days to figure out how to do that, since this is the first time. And yeah, please come again. I suspect we'll have another one within about 2 to 3 weeks as we kind of recap how this all went. So thanks, and talk to you soon.
Yeah, thanks everybody. Appreciate your time.